Hello everyone, in this video we will discuss representation of vectors and types of vectors. Vectors is a physical quantity which has both magnitude and direction, and it also follows vector law of addition. Electric current is not a vector quantity while it has both magnitude and direction because it does not follow vector law of addition. So criteria for a vector: magnitude, direction, and it also follow vector law of addition. Now we will discuss the representation of vector. A vector is represented by either capital letter or a small letter having arrow on its head. Here vector A is represented by both in capital letters and in a small letter. In same way, vector P is represented with letter P having arrow on its head. How can we represent magnitude of a vector? Suppose we have vector A, then its magnitude can be written as mod of vector A. In some book, a vector is also represented by a bold letter. This is the vector A, either in bold letter or in letter having arrow on its head. Graphical representation of vector. Magnitude of a vector on graph paper is the length of the vector. For example, we have vector P, end point or originating point is called tail, and terminating or arrow is called head of the vector. Suppose originating point is A and terminating point is B, then length of line segment AB is the magnitude of vector P. Suppose we have a vector P on any plane and another vector Q is in same plane. Here magnitude of vector P is less than that of magnitude of vector Q because length of vector P is less than length of vector Q. Graphical representation of a vector. Suppose we have vector A on xy plane. O is originating point or tail of vector and B is head of vector or terminating point. Theta is called angular direction of vector A with respect to x-axis. Angular direction of vector A with respect to x-axis. Then OB will be magnitude of vector A, and there will be two components of vector A, one along x-axis and one along y-axis. OA will be component of vector OA will be component of vector A along x-axis, so this will be called horizontal component of vector A. OA equal to AX and OC equal to AY. AX mean horizontal component of vector A, OC mean vertical component of vector A, and we know theta is the angular direction of vector A with the x-axis. Now so many types of vector. We will discuss some of them. First we will discuss null vector. Null vector are those vector which having magnitude 0. We can find null vector if we add 2 or more vector, then get 0 vector. That will be called null vector. There is no specific direction for null vector. That means direction of null vector is not defined. It has arbitrary direction. So if sum of 2 or more vector is 0, then this is called 0 vector or null vector. For example, a block is kept on a horizontal plane, a smooth horizontal plane, and its weight is mg, acting vertically downward, then ground will also apply the normal reaction, and there are two forces, one having magnitude 30 Newton and another having also magnitude 30 Newton, acting along the horizontal. Then these two forces will be cancelled out. Similarly, mg and normal reaction will also cancel out to each other. So we get null vector when we will add these all four forces. Therefore F1 plus F2 plus n vector, normal vector, and weight is also force. A force is a vector, and we are getting total result 0 vector. So this will be null vector. In same way we can say that if you go from school and return back to your home, then there is a displacement vector is 0 vector. Direction of null vector is not defined. It has arbitrary direction. Now define unit vector. A vector is said to be unit vector of a vector if it has unit magnitude of that vector and a small vector have same direction that of bigger vector. Unit, that is called unit vector. Unit mean 1. Unit vector has magnitude 1. So we can define a vector is said to be unit vector if it has unit magnitude of that vector and same direction of that vector. For example, suppose we have a vector p and a small vector is unit vector of vector p, then vector p unit vector can be written as letter p having cap on it. So p cap is called unit vector of vector p, and unit vector is given as vector upon its own magnitude. Mode of p is also p. So unit vector p can be written as a p vector divided by magnitude of p. For p magnitude is equal to p vector. So therefore for 1 unit magnitude, the vector can be written as p vector divided by p. Vector p divided by p is equal to unit vector of vector p. Hence, any vector divided by its magnitude is called unit vector of that vector. For example, force vector divided by magnitude of force is unit vector of force. Now we will discuss equal vector. Two vector is said to be equal vector if it has same direction and same magnitude. For example, suppose we have vector p like this and another vector q like this. Both vector having same direction, that means they are parallel to each other and having same magnitude, that means length of vector p is equal to length of vector q, and they have same direction, so vector p can be written as vector q. And another vector is also parallel and having same magnitude, those of vector p and q. So all three vectors are equal vectors. Now discuss negative vector. Two vector is said to be negative vector if it has equal magnitude but opposite direction. For example, vector here is vector A having some magnitude and another vector P having same magnitude but exactly opposite direction. So vector A can be written as minus of vector P, or vector P can be written as minus of vector A. So A and P are negative vector. Co-initial vector. Two or more vector is said to be co-initial vector if these are terminating out from same point, or in other words, these all vectors having same originating points. Now discuss coplanar vectors. Coplanar mean what? Co means same, plan matlab plane, a vector having same plane known as coplanar vector. Here vector A, vector C and vector B are coplanar because these are lying in the same plane. But in second case, we have two different planes, xy plane and yz plane. We are going to draw vector A in yz plane like this, vector A, and vector B in yx plane. Vector A and vector B will be not coplanar vector because these two are in different plane, but vector B and vector C will be coplanar vector because this is lying on yx plane. Similarly, D and A are coplanar vector. Now discuss position vector. A vector which gives us idea of a position of a particle from origin, known as position vector. Suppose a particle is located in a xy plane 10 meter away from origin. At point B, O is the origin, 10 meter is the distance of particle, straight distance of particle from origin. In other words, particle is 8 meter away in x-axis and 6 meter away in y-axis. So the coordinate of particle is 8, 6, and OB is the distance of particle from origin. That means straight distance. OB is position vector, that will be equal to r vector, and there will be two components of position vector, rx and ry. Rx will be 8 meter and ry will be equal to 6 meter. To represent position vector into vector form, we have to know orthogonal unit vector. Orthogonal unit vector is I cap, j cap and k cap. Ortho means perpendicular to each other. These unit vectors are perpendicular to each other or normal to each other. So their name is orthogonal unit vectors. I cap along x-axis, j cap along y-axis, and k cap along z-axis. We have three axes, x-axis and y-axis and z-axis. X is along y, x I cap is along x-axis and j is along y-axis and k is along z-axis. Now we can write down position vector of particle into orthogonal unit vector. R vector equal to Rx I cap plus Ry j cap. Rx is the horizontal component of position vector. Ry is the vertical component of position vector. Further we can write Rx is equal to 8, so 8 I cap plus 6 j cap. We can also find out magnitude. This is known. Magnitude of position vector is 10 meter. Let's check it. By using Pythagoras, we are seeing a right angle triangle, base with 8 meter and altitude 6 meter. So hypotenuse r can be written as 8 square plus 6 square, that is 10 meter. Root of 100 is 10 meter. This is position magnitude of position vector OB. OB is the magnitude of position vector. So this is true. Polar vector, defined as the vector whose starting or originating point is known as polar vector. These are example of polar vector. For example, velocity of a particle is given as 2 meter per second and 8 meter per second. It has a starting point and terminating point. So when we join a starting point and terminating point, then there will be a line. So polar vector belongs to a straight line. So example of polar vector are force, velocity, acceleration, etc. Now discuss axial vector. When a particle rotates on a circle or rotating about any axis, then the vector related to this vector is called axial vector. For example, a particle is moving on a circle. After some small time dt, it has angular displacement d theta. Then angular speed can be written as d theta by dt. This is called angular velocity, and this is example of axial vector. The speed is angular velocity is example of axial vector. In same manner, torque is also axial vector. Axial vectors are cross product of polar vectors. For example, torque is cross product of position vector and force vector. We will discuss cross product, dot product in the later part of the chapter. Torque is given by R cross F, where R is position vector and F is force vector. Direction of polar vector is given by right hand thumb rule or Maxwell cork screw rule. By this rule we can find out direction of polar vector. Once again, hi everyone. If you like the videos, please subscribe my channel.